Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. In this video lecture series, we are discussing the subject called Object Technologies and Programming in Java, that is OTNP. And today we are going to start a new topic called Input Output in Java. Now I'm not going to dwell too much on this topic because it's just a one third of a unit only, and it's quite a broad topic. If you try to, it's actually quite a large library itself. If you try to go through each and every class and its methods, it will take around a month or 10 to 15 lectures in that. So I'm briefly going to discuss about the types of streams that Java offered to us, and in the next lecture we will try to see how to write to console, how to read from the console, and how to write to a file and how to read from the file. So this is basically uh, is going to be my complete let's say sorry, this is going to be my complete outline of the this lecture and the last lecture, that is the input output topic. So let's begin with. Now, so far we have used variables and arrays for storing data inside the programs or applications. This approach poses some of the problems. First is the data is lost either when the variable goes out of the scope or when the program is terminated. And that is, the storage is not permanent. Now it is difficult to handle large volumes of data using variables and arrays. As you can see that for the most practical applications, the mostly your data is read from or written to from some external source or files, not in the internal memories. And those external source and files, you cannot deal with them with using your basic arrays and variables. Now to overcome these problems by storing data on a secondary storage devices such as floppy disk or hard disk, that is your servers, the data is stored in these devices using the concept of files. Now, data is stored in files is often called the persistent data. Okay. Now let's move ahead to the slides. I have arranged some slides for you. Okay. Now this is your actual file system used in Java. So I will begin from the top. Let's say a file is actually a collection of records. Now this is actually a single file and it has 4 records for the person called Vijay, Mani, Lata and John, and we have some different fields there. Okay, each field for a particular individual can be termed as a record. The record is composed of several fields, and a field is a group of characters, as you can see here. Now John is a particular field, 1001 could be a particular field, maybe its unique ID, and 70.50 maybe its marks could be a unique field. So all these fields combinedly will consist or will make a record, and the collection of records can be stored inside a file. Okay. The characters in Java are actually Unicode characters and composed of 2 bytes. So each byte containing 8 binary digits, ones and zeros. So you can see that this particular field is consist of characters, and each characters in actuality is composed of 2 bytes of data. So that is actually the Unicode characters, Unicode, let's say, encoding of your characters. Okay, you must be familiar with that. Now, this type of storing and managing data using files is known as file processing, which includes tasks such as creating files, updating files, and manipulation of data. Now, Java supports many powerful features for managing input and output of data using files. Reading and writing of data in a file can be done at the level of bytes or characters or fields depending on the requirement of a particular application. Java also provides capabilities to read and write class object directly. Okay, so I will not go in detail to that. So we'll move ahead. Now we have seen what is the complete hierarchy of the file system in Java. So let's move ahead, or we can say how you can, what you can call a file in Java. Okay, let's move ahead. Okay. Now let's begin with the concept of streams. Now in file processing, the input refers to the flow of data into a application and output means the flow of data out of to the application. Now input to application may come from a keyboard, mouse, memory, disk, network, and some other things as you can see here. So your Java application is actually fetching some data, either can be from your keyboard or from mouse or memory disk whatsoever. And in the same way, output from a application may go to the screen, the printer, memory disk, and some other things as you can see here. This is your this particular part of the figure displays how a Java application is outputting some information to these particular peripheral devices. Okay. Now, these devices look very different at the hardware level, but they share certain common characteristics such as the unidirectional movement of data, creating data as a sequence of bytes or characters, support to the sequential access to the data. Okay, so they have some common threads. Now, Java uses the concepts of streams to represent the ordered sequence of data, a common characteristic shared by all input-output devices as stated above. Now, a stream presents a uniform, easy to use, object oriented interface between the application and the input output devices. That is, now these are your input output devices, the sources and destinations. So, an interface which is actually uniform, easy to use, and actually implements the object oriented methodology are called streams in Java. Now, stream in Java is path along which data flows. As you can see, the data is flowing outside of the to the out of the application or coming inside the application. Either from your application is taking your data from the sources, or it is giving your data, or let's say outputting something to the destinations itself. Now, both sources and destinations may be physical devices or some other things. So let's move ahead. Now, here we can see the actual uh, data in a visualization mode. So the concept of sending data from one stream to another has made streams in Java a powerful tool for file processing. We can build a complex file processing sequence using a series of simple stream operations. This feature can be used to filter data along the pipeline of streams so that we obtain data in a desired format. Okay, now for example, we can use one stream to get raw data in binary format and then use another stream in series to convert it to the integers. We'll see in a while how many different streams we have and what different streams do, and you will find out that we have two streams which are both a type of input streams, and one of them actually reads the raw data and other one actually reads the data and also side by side it converts the data. Okay, so that is why we have called the input streams of Java so powerful. Okay, let's move ahead. Now this is the stream hierarchy in Java. Now streams are classified into two basic types, namely input stream and output stream. An input stream extracts or reads the data from a file and sends it to the or transmit it to the application. Similarly, an output stream takes data from the let's say from other application or let's say and or maybe some other device and sends it to the destination. Now, as you can see in the following slide, we have I have depicted the two main basic streams. The first is the byte stream class, and next one is the character stream class. And in both of these streams, if you can focus that we have a type of input stream, that is the input stream class, and in the character stream class it is called as reader class, and a type of output stream class. In the byte stream class it is called as output stream class, and in character stream class it is called as the writer stream class. Okay. Okay, so let's move ahead. So the application connects and opens an input stream on the data source and then reads the data serially. And similarly, an application connects and opens an output stream to the destination place of the data and write data to it. So this is how we'll move on. Now, first of all, let's look to the let me tell you the what kind of package you need to access these stream classes. The java.io. The java.io package contains a large number of stream classes that provide capabilities for processing all types of data. Now, these classes may be categorized into two groups based on the data types on which they operate. Now, the first one is the byte stream class that provides support for handling input output operation on bytes. Let me remind you, the one byte is equivalent to 8 bits of data. And the second stream is actually your character stream class or the classes that provide support for managing input output operations on the characters itself. So it is not concerned with how much amount of byte data you are getting in. It only reads the data in the form of characters or converts it into characters if it is not in that particular form. Okay. Now these two groups may further be classified based on their purpose. As we have already discussed, the byte stream and the character stream classes contain the specialized classes to deal with input and output operations independently on various types of devices. We can also cross group the streams based on the type of source destination they read from or the write. Okay, so can further move ahead. Now first we'll discuss quite, let's say for next 5 to 6 minutes I will discuss the byte stream input class. Actually this is the most important type of stream input class because you may not know what kind of data you are going to have at some times. And also the byte stream input class reads the data in the form of byte. Now that byte data can be of any conventional data type, let's say of integer form, or could be characters or strings or maybe an exe file or some other application or something else. As you can know, everything inside your systems can be encoded into the bytes of data that is in the form of Unicode. So this particular stream class provides you with extreme flexibility. Okay, now let's move ahead. Let's discuss about the byte stream class. Okay, now there it is, the byte stream class. The byte stream classes have been designed to provide functional features for creating and manipulating streams and files for reading and writing in bytes only. Since the streams are unidirectional, that is they either sense data or they accept the data, they don't do both at the same time, so they are unidirectional in nature. They can transmit the bytes in only one direction. Okay, so therefore Java provides two kind of byte streams, that is an input stream and one is your output stream. Okay, that is, now we are going to discuss the input stream for a while. Now input stream classes are that are used to read the 8-bit byte include a superclass known as the input stream. As you can see, now this is your superclass and the number of subclasses for supporting various input output functions. Okay, now the superclass called input stream class is actually an abstract class and therefore we cannot create instance of this class. Rather, we must use the subclasses that inherit from this class. Okay, so the input stream class is actually an abstract class, so you cannot instantiate it, but you can extend it. Now input stream class defines methods which must be implemented by all the other classes, that is file input stream class, pipe input stream class, byte array input stream class, file input, string buffered input, object input stream class, and sequence input stream classes. These few methods are implemented by all these classes, which is defined in the abstract superclass called input stream class. Now let's see what methods are there. Okay, the first method is your read method. Now let me again remind you, all these methods are defined actually in your input stream abstract class. Okay, oops. No, let's start. So first is your read method. It reads a byte from input stream. That is simple. Okay. Next one is your read, and where you will pass an argument. That is an array of bytes. So it reads an array of bytes and then put it inside the B. So B is an array, that is the continuous memory location reserved for storing an array of data which is being read by the your input stream, one of your byte input stream classes. Okay. Now next one is your read method again, but with a different constructor. In this case, we have also passed two integer variables called n and m. So what is the basic functionality of this method is it reads the n bytes of data and store it inside the B array starting from the nth byte. So you can choose from which byte you actually wants to read the data. Okay, and okay, there must be a mistake. There must be, instead of n, you can correct this. This must be m. Okay, so it reads the m bytes into the B array and starting from the nth byte. So you can choose how many bytes. You can choose from which byte you want to read your data. Next is the available method. Okay, now this method actually gives number of bytes available in input, or how much data still is left to be read out. Next one is skip, and you will pass an argument called as n, and it will basically skip over n bytes from the input. So that is simple, I think. Next one is there are reset. Goes back to the beginning of the stream, that is from where you have started actually to inputting your data or reading from a particular stream. Okay, and last one is close, which will actually close the input stream. It's quite important because if you have opened up a stream, it is mandatory to close that stream, and these kind of if you don't close a stream that you have opened up, or if you don't close a particular file, it may end up in compilation error. Okay, so you must be quite vigilant about it. Okay, so what is left? So let's move ahead to the output stream class of the byte stream, and there it is. Now output stream classes are derived from base class called output stream. Okay, now in the last case that the abstract superclass called input stream is the basic class. In this case the same role has been done by the output stream, and like input stream, the output stream is an abstract class, and therefore we cannot instantiate it. Several subclasses of the input stream or the output stream can be used for performing the output functions or operations. The main functions are writing the bytes, closing up the streams, and flushing the stream. That is, clearing up the streams of any garbage values or the previous unread, let's say unwritten files or the data that is present. Now we have several other file subclasses which actually implements the extends the superclass called output stream, that is the file output stream, piped output stream, filter output streams, byte array output streams, and object. As their name specifies, one is dealing with the objects, that is outputting the objects. Other one is the byte array, that is outputting the data in the bulk in the form of byte arrays. Second one is file, that is dealing with a particular file, and the next one is piped, that is dealing with the pipes, as you must be familiar with the piped system in your operating system. Okay, so every one particular class deals with some particular let's say either in the bulk of data or in the smaller chunks of data, and either to a particular file that can be stored at anywhere, or to another stream, or to some pipeline. Okay, everyone has its own specific use. I will not go into the detail because each one of these classes will require at least 2 lectures to discuss in detail, and I think you people must not focus too much on the great detail in all of these, because this is just only 1/3 of a unit, and then again you have to go through the whole, let's say, syllabus, and you will not be able to complete the syllabus in time if you focus too much. So I'm just going to introduce to you what input, output, and streaming classes means in Java. So let's move ahead. Okay, now these are the few functions that we have. Okay, that is being defined in the output stream abstract class. So first one is like in the previous input stream class, we have the write, because it's an output stream class. So this particularly writes a byte to the output stream. So this particular method is meant for a single byte only. So you have to write multiple bytes. Either you have to call this particular method inside a loop, or you have to use some other method. Now the next one is the same method but with a different constructor. It accepts a different argument. It accepts an argument of the character, or sorry, the byte array called b, and what it does is it write all the bytes in array b. Okay, the array spelling is wrong, so you must insert an a here. Array b to the output stream. So if you have multiple bytes of data, you can use this particular method. Now next is the write method, again with a different constructor, and it accepts a different set of arguments. So in this particular method, we have the flexibility of choosing how many bytes of data and starting from which byte. Okay, so we can write m bytes of data which are actually stored in the array b, starting from the nth byte. So it provides us with the flexibility of selecting the data which we actually want to output. The second last one is the close. As the name specify, it is used to close the output stream. And last one is the flush, so that any data that has been not accepted, or the garbage data, can be terminated out of the stream. Okay, so I think I have made myself pretty clear now. And okay, I think we have discussed in briefly about the byte class stream. So let's move ahead to the character class stream. Okay, like in the byte class stream, we have a character stream which deals only and only with in the form of character. So if you have inputted some data, okay, in the form of, let's say, uh, in the form of integer or float, this particular stream, I can say few of the classes that are in this particular stream, character stream, have methods which will first convert that particular data into the character, and then will only allow you to either input or output the data. So the type of data which we are going to use or deal with in this particular class is strictly your character data. Okay, so I think I have made myself pretty clear now. Now we have two classes here. Okay, first one is the writer class. Now this writer class is actually an output stream class, so you can say this is synonym to the output stream class of the byte stream. So this particular class basically deals with, or it basically deals with writing to the outputs. That might be some files, or that might be some pipelines, or that might be some other streams. Okay, and the next one is actually your reader class. And then again, you can again associate this particular class called the reader class to the input stream class of your byte stream class or byte stream. Okay. uh, in that particular stream class, that is input stream class, we have dealt with inputting the data in the form of bytes only, but here we will deal with inputting the data or reading the data from particular, let's say, peripheral devices or some other pipelines or some other, let's say, streams in the form of character only. Okay. Okay. So I think this one is getting too long. So I'll just show you how many different subclasses we have. Now reader class and writer class are the again the abstract superclasses, and we have subclasses called the buffered reader, character array reader, input stream reader, filter reader, pipe reader, and string reader. As their name suggests, they are actually dealing with different types of, let's say, the bulk, the amount of data, and different types of your destiny. Let's say, in this case, different types of sources. So, if I briefly tell you about it, now character like this character array reader or char array reader class, actually it's an input stream that reads from a character array. Okay, now your buffered reader actually buffered input character stream. It's an now input stream reader. This particular input stream is the stream which actually translates the byte to characters. As I have told you, this particular stream class called the character stream actually deals only with in the, let's say, with the character data. So you can say, if you have some data which is not in the form of, let's say, characters, so what we'll do is we'll use the input stream reader class, which actually first converts the byte of data into characters, and then it will start reading. It will let the stream flow with the data. Okay. And then we have filter reader, which actually filters the data which you are going to read. I will tell you about it in a line or so in the next lecture. And that is it. The other few names will make sense by their name only. Like the pipe reader, we are going to read the characters from some pipeline, and the string reader, which actually read the the complete string, not single characters, but in the form of complete strings. Okay. So let's move ahead to the last slide, that is the writer class. And here again you can see that we have a abstract superclass called writer, and we have few of the subclasses which actually uh, extends this particular class. And few of the classes named here are the buffered writer class, which is used for buffered output character stream. And then we have char array writer, which is the output stream that writes to the character array. And then we have output stream writer, okay, uh, which actually translates the characters to the bytes. So if you have a destination to whom which you want to write, and if you are using the character array, sorry, the character stream class, then you have to use, and it that oh sorry, I think I have moved on. So let's get back here. And in that, if you want your data not to be stored in the form of characters but in the form of data, so this it will convert your character data into bytes. Actually, it is in the form of bytes, but it will break it down in the form of bytes, and its identity now will be in the form of bytes rather than in the form of characters. Okay. And I think next 3 to 4 months will make their sense from their name itself. So I'll end this lecture now, and tomorrow we'll see the live examples, how to read from a file, how to write to a file, and how to read from a console, and how to write to the console, and a few of the small topics left in this particular let's say portion of your data. So thank you.